So the presentation is going to be about Mixel MIPI portfolio. So we are very much focused on MIPI. So to make this presentation relevant, it would be good to know who has heard about MIPI before. So some have never heard of MIPI, some have. So yeah, so we have been focused on MIPI since 2006. We have been supporting mixed signal IPs for about 17 years now. MIPI is an alliance of companies, hundreds of companies that basically collaborate to support, originally to support the mobile platform. And in the many years, recent years, it's proliferating beyond mobile. So just to kind of give you a quick background, this is the market segments that MIPI has been engaged in and supporting. Certainly the first one is the mobile. A lot of use now in IoT and automotive, quite a bit in wearable. Maybe the next thing coming up might be medical. In terms of applications, the majority of the applications today are camera. So there is a camera serial interface, which is CSI. There is a display DSI. Those probably are the largest two applications. And then there is quite a few chip-to-chip communications as well. This MIPI system diagram is for mobile applications. Okay, so basically this is all the different components in a mobile platform, and I guess I'll move on this side. So you have the application processor, you have a modem, you have an RFIC, you have a wireless LAN, you have a Bluetooth, you have audio, mesh storage, and power management, sensor hubs. You have, of course, the display, the camera, and other things, right? So it shows here that the MIPI Alliance has developed three PHYs so far. One is the MPHY, one is the D-PHY, one is the C-PHY. Okay, and the color code here show you where it is used. Okay, so MPHY is used for UFS, for example. For display and camera, DSI, CSI, multiple PHYs support that. So for example, the display is supported by both D-PHY and C-PHY, camera, C-PHY, D-PHY, and MPHY. So you can see a lot of different uses for the PHYs, this color code shows you if it's chip-to-chip or multimedia. Mixel focuses on those two areas because this is the area where high data rate applications are, and that is where our focus is. Our focus on the physical layer, high data rate physical layer. So that, of course, there is audio, there is a lot of other things that are low frequency that we do not participate in. This is another system diagram for auto applications. Auto is probably the second largest focus for MIPI in terms of adoption, and you can see this is this shows a car. You can see here the infotainment telematics hub. This is basically the dashboard here. You can see in the back you might have multiple displays. Of course, in the front you have multiple displays. You have cameras. Typically nowadays cars might have 4 or 6 going to 8 and 12. You also have audio, display gauges, sensors. So sensors would be, for example, sensing the distance to surrounding environment, other cars. So you see a lot of basically a lot of the interconnect is using MIPI. The only part that is not really pure MIPI is a network bridge, where you are going from MIPI to some other higher data rate application to go a long distance. So MIPI is a mobile platform originally targeted for low power and short distance. Automobile, of course, is much larger entity, and that's where the bridge chips comes in. So basically, some of our customers, yeah. Okay, so that's where we are. I think we covered this well enough. So let me give you a little bit of background about Mixel and MIPI. So as I said, we are very much focused on low power physical layer. MIPI is certainly very much fits the bill. And we have concentrated that for about 10 years now. We provide a complete solution to the customer, which means the PHY, the controller, infrastructure. We believe we have a differentiated solution in terms of power, area, performance, features, and I'll get a little bit more into that. We have our over 73 licenses, meaning we have sold MIPI PHY so many times. We have silicon proven and licensed the MIPI technology in 7 different nodes, 7 different foundries. So we work with all the major foundries, and we cover a lot of the nodes, advanced nodes, as well as the older nodes. We also have a MIPI platform which incorporates our test chip with a FPGA board. So our RTL gets integrated into the FPGA. The customer can integrate their own RTL into the FPGA, and very quickly you can have a working demo, for example, or proof of concept for your product. We have also developed an ecosystem, call it Mixel MIPI Central, where we have a tier 1 ecosystem supply chain that covers PHY, the controller, the VIP, instrumentation, testing, and so that basically helps you go through the process very quickly at low risk. This is a block diagram of the D-PHY. As I mentioned, there are 3 PHYs. This is the older PHYs. It has the widest adoption in the industry. It is a source synchronous PHY, so you basically transmit both the data and the clock. So there is a clock lane, so you don't need to recover clock. It has low power operation, high speed operation, and because of all of this, you can really optimize the power. Here you see the high speed transmit, low power transmit, high speed receive, low power receive. There is a contention detector because this can be turned around. Of course, you have the serializer, the deserializer, logic to state machines and things of that nature. So this is a universal lane, meaning it has both the transmit and the receive. So you can use it for any of the D-PHY applications. Now, of course, we have developed different flavors. So we have IP that is only transmitter, have an IP that's only receiver. We also have IPs that kind of tries to get the best out of the receiver and the universal lane. And I'll talk a little bit more about that. This is the kind of board with our test chip that I was talking about. We provide the whole complete solution, including the PHY, the controller. It supports CSI, DSI, CSI, which is the most common uses for the D-PHY today. So this particular PHY supports 2.5 gig operation. This is a new configuration. Well, I mean, it has been around for a couple of years, but it's a unique Mixel configuration that is compliant with the receiver configuration from the MIPI Alliance. And basically, in the D-PHY, the receiver is a smaller area, quite smaller than the transmitter. And the reason for that is it's source synchronous, so you do not need to do CDR, so the receiver tend to be much smaller. So this actually configuration was developed in collaboration with one of our automotive customers, where testability is very important. In-system test, full speed testability in system and on the production floor are very important, while of course the area and the power is just as important. So basically this configuration eliminates multiple transmitters that the regular configuration would have. And by doing that, area is smaller, the ability to lower the power, and this has been already silicon proven in 40 nanometer and 28. It's already in production in 40 nanometer and in automotive applications, and going to production in 28. Yeah. One of the PHYs I mentioned is the C-PHY. The C-PHY is the newest PHY in the MIPI Alliance, and it's basically the clock is embedded, so you don't waste a lane for the clock. On the other hand, it is not your classical embedded clock, so I'll mention more about the C-PHY in the next slide. Basically, this is a combo IP that we have that both has the C-PHY and the D-PHY. And the attractive thing about that is because the D-PHY is very widely adopted, this is what people want to make sure they have, but they also want to have a smooth transition to go to the C-PHY. And I believe we are the only company that has this in silicon that enable our customer to do both. So basically, the same IP, the same chip can be used for both the C-PHY and the D-PHY. They do share the low power operation. So the idea behind the combo is you can share the low power operation. You can also use, which of course is the low speed operation. Then you can also share a lot of, you're sharing the same pins, you're sharing the same traces on the board. We are sharing a lot of the common circuitry on the PHY. And this is basically the D-PHY part of this combo, which is not different from a regular D-PHY, right? Of course, this is an advanced type of D-PHY that has the deskewing built in, because as I mentioned, the D-PHY is a source synchronous. So at higher speed, you have to do deskewing, which is supported by the standard. So it's kind of automatic calibration. And it works up to 10 gigs, so 2.5 gig per lane times 4. That would be the bandwidth. The C-PHY version of this is what we are looking at here. It also supports camera and display. The C-PHY is a 3-phase symbol encoded PHY, which means that really you don't have to have a classical or traditional CDR to recover the clock. Basically, you're just detecting the edges, so you can save a lot of power and at higher data rate. So this runs at 2.5 gigasymbol per second. The encoding allows for about 2.82 bits per symbol, so you end up with like almost 6 gig for one lane, which gives you for like 3 lanes, because it's a trio, you end up with maybe about 17 gigabit per second. This is seeing quite a bit of adoption on the sensor side. So we have multiple customers that have already licensed this IP in multiple nodes that targeting the sensor application. This is the MPHY. The MPHY has been around for quite a while. It's a classical CDR type of PHY. Currently, high-speed gear 3 is running at 6 gig. Next generation is high-speed gear 4, which is running at 12 gig. You have the PLL, transmitter PLL, you have the transmitter, high-speed transmitter, which also work in lower speed modes. So nothing unusual here. Again, the receiver is very classical type of receiver with receiver, the CDR, the deserializer. Then there is quite a bit of logic in terms of state machine, many different power down save states that require sophisticated state machine. We have had the MIPI silicon proven for many years now. Again, we have a platform that supports that, and this just shows the test chips, the different boards that we have built over the years, and the performance. Yeah. We deliver, have a full list of deliverables. Of course, GDS, the specifications, design guidelines, integration guidelines, LEF, the timing models, IBIS, RTL, test benches, and I think most important is outstanding customer support to production. So in conclusion, Mixel is a mixed signal IP company that has been in business for over 17 years now. We have been always focused on mixed signal physical layer. In the last years, we have focused on MIPI, and we believe we are the leader in the MIPI PHY segment. We have established a robust ecosystem supply chain that enable our customers to go to production very quickly with very low risk. We believe that the platform that we provide to our customer enable our customer to integrate the RTL and have a platform that they can use for their own development very quickly. We continue to innovate in MIPI by introducing a combo that is unique for the C5 D-PHY RX configuration that nobody in the industry has. And we like to say we put IP in MIPI, and we hope that when you think about MIPI, you think of Mixel. Thanks. Any questions, comments?